Today, last week we did addition, subtraction, and multiplication of polynomials. Today we're going to do division of polynomials. This doesn't go with what we did yesterday. Yesterday I did a lesson that doesn't really go with anything we're doing right now, just because if the people who missed it, it wouldn't be horribly, like it wouldn't throw off what they're doing. Although it will be on our quiz Friday, what we did yesterday. Every Friday. So today, we're doing division. We're only doing two kinds of division today. The first kind is like this.
Wait a minute, so seniors missed a quiz in here Friday too?
Oh, dang it, I need to make that up. We'll make that up tomorrow. Okay. Shh. All right. Hush. Here's what we're doing first. We're going to have a polynomial divided by a monomial. That's the first thing we're going to do. Now, we did this last week. We really did. Just do one piece at a time. If I was doing that piece, what's 6 divided by 3?
2.
2. What's a divided by a? Nothing. They just cancel. What's b squared divided by b? B. Yeah, 2 minus 1. Remember you just subtract the exponents? That'd be b. Minus 3 divided by 3 is 1. A squared divided by a? And b divided by b? Exactly. Division, polynomial by a monomial, that's really all there is to it. Let me show you the one straight from the book.
Is that all we're doing?
No, we're doing one other thing. But the other thing, it's very different than that, but it's really, it's not hard once you see an example or two. All right, here's 3 quick examples from the book, 2 of which have answers next to them. Why didn't this show up? Here it goes. All right, so let's just talk about 15. It's just like the one we just did. 9 divided by 3 is 3. 3 a's divided by 2 a's is 1a. 2 b's divided by 1b is 1b. Minus 18 divided by 3 is 6. The 2 a's cancel. 3 b's divided by 1b is 2 b's. Questions about 15?
Okay, so if it's just like A and A, then it just cancel out.
Yes, if they have the same power, they just cancel.
Oh, right.
Now, if you notice, the ones I'm giving you today, they don't even have, remember how the ones we had last week, there was sometimes bigger stuff in the denominator, you had to figure out where it went? That's not even an issue today. You don't even have to worry about that. Now, 15, 17, and 19 are all the exact same kind of problem. They're just written in 3 different ways. The whole reason I wanted to show you all 3 of those is to show you, they could ask you to divide these things in 3 different ways. They could put it to you as a fraction, which is probably the easiest way. They could literally write it as a division problem, which is the same exact thing, except it's not written as a fraction. And what did we learn last week that negative exponents do?
They divide it.
They move to the denominator, right? Or if they're in the bottom, they move to the top. So really, that says this times 1 over this, which is the same as, let's look at number 19. Number 19 is the exact same as the other 2, but when you multiply something with a negative exponent, gentlemen, make sure you're paying attention. When you multiply something with a negative exponent, it's going to work out like this. 2y cubed z plus 4y squared z squared minus 8y to the 4th z to the 5th. Now, when you multiply by yz to the negative 1, you really have to flip that to the denominator, and then you're just doing this, which is what we just did a second ago. 2 divided by 1 is 2. Oh, I'm sorry, hold on. So we're going to go through this. 2 divided by 1 is 2. 3y's divided by 1y is 2y's. 4 divided by 1 is 4. What?
Where do you get y1 on the bottom? Well, why is there not a
So
1
the
next to the z?
parentheses is separate.
I just wrote that in there just as we were doing it. Really, anytime there's no power, you just assume it's a 1. I just wrote that in there for a second. Come in. I just wrote that in there.
Sorry to interrupt. Can I say Jeree for just a second?
Sure. Okay, moving on. So, 2y's divided by 1y is 1y. 2z's divided by 1z is 1z. 8 divided by 1 is negative 8. 4, 1. Look on the board. Is there something that you're like, hey, where did they get some part of this answer?
Well, let me look at it.
Okay.
So
What?
why would you not go like this?
Because they're not like terms. You can't add and subtract things that aren't like, they have to be literally the exact same. You can only add or subtract if like, they, Now, even if this was a cube, we still couldn't put it with that one because this one has a z on it.
So if that, the two y squared had a z on it, you could add it to the 4y cubed.
Say that one more time. What? No, so like if this was 2y cubed z to the fourth, this also has y cubed z to the fourth, and you could put those together, like 2 minus 8, negative 6, y cubed z to the fourth. But they have to be the exact same when you add and subtract. Yes?
Okay, so you set that one up as a fraction separated
Gentlemen.
by,
Go on.
separated by the parentheses. But
Yes.
number 17, since it's division
Uh-huh.
and not multiplication, would you set it the same way?
Yeah, it'll be this divided by 14 CD. All three of these are like the same problem. They're just written in 3 different ways.
So it doesn't matter if it's multiplication or division.
Nope. And I'm not going to give you 3 of these on Friday. Well, I don't think I'll give you 3 of these on Friday. But I might give them to you in any of these forms. Here's a hint. Just which way do you think I'd give it to you? Now, bear in mind, ideally, I want to give you a problem that makes you remember other things we've learned. So which one of these is kind of the most...
15.
What?
15.
15 is probably the most straightforward one, but which one of these is something that you'll have to remember other things we've learned to do? 19. You're probably going to see one like 19 because you're going to have to remember what negative exponents do and how all that works. And that way it's like a cumulative problem. So you pretty much can guarantee yourself to see one like 19. 15 is a possibility too. And 17 is as well, but 15 and 19 are probably the money problems. All right, questions on those? Great. All right, fun stuff now. You probably did this in Algebra 1, but I love it. What I'm going to teach you now is called synthetic division. When you have a polynomial and you divide by a binomial, who remembers what a binomial is?
2 times.
Yeah, exactly, 2 terms. Then, when you have that, then you get to do synthetic division. Ooh, I'm getting goosebumps. This stuff is so fun. All right, now you're wondering if I'm serious or not. Oh, I'm serious.
Probably something outrageously hard.
It's not outrageously hard. It's really not.
It's just outrageously easy.
I don't know about outrageously easy, but it can be pretty
You
easy.
get all the problem in 30 minutes.
Yeah, I'll just erase that one. We'll come back to that later. Okay, here we go. Here's all you have to do. Now pay attention, because if you miss this, you're going to be like, what? But if you pay attention, this is really not that bad. When you divide a polynomial by a binomial, this is all you have to do. And it's kind of cool how it works out. Now I could show you long division, but nobody likes to do long division. So I'm going to show you a quicker way. And it's called synthetic division. You aren't even going to have to deal with the letters. I know. How awesome is that? Not really. So here's what you have to do. 21. First thing you do, you take the opposite of the number you're dividing by. Every time you divide by a binomial, it's always going to be a letter plus or minus a number. Always. And that letter will always be the same as those letters. That's kind of the whole point of synthetic division.
So it's going to be plus 2.
Exactly. You always take the opposite of the number that you're dividing by. So instead of negative 2, you're going to write down positive 2 and put it in a little box. Again, I would highly recommend you follow along with this example, because later, when you go to look at this, you're going to be like, where did he get all this stuff? But if you have an example or two, it's going to be staring you in the face. You take the opposite of the number you're dividing by. Next, right next to that, you write all the coefficients in order. What's the number in front of the b cubed? 1. In front of the b squared? In front of the b? Yes. Now, this is the step. Warning, warning, warning. Just like last week. Remember I told you last week that people were going to miss the FOIL problem because they were just going to square this one and square this one, and sure enough, a lot of people did that. Here's the mistake a lot of people are going to make this week. When you do synthetic divisions, you cannot be missing any term. Look at 23 and look at 21. Is 21 missing something that 23 has? Look, we have a third power, a second power, a first power.
Yeah, it has more numbers.
It has a number at the end. You can't be missing a term. Whatever you start with, you have to have a number for every term you could possibly have. There's no number at the end. So whenever you're missing something, you have to put in a 0 as a placeholder. Otherwise, your variables are not going to line up when you're done. So, 1
Why are you
B.
doing that for two different problems?
What?
Why are you doing that for two different problems?
Oh, no, I'm just doing 21. But I'm showing you that it didn't have a number like this one did.
So there has to be 4?
Well, there has to be one for every, like this one should have 5, because it started to the 4th. It'll always have, that's a good question. It'll always have one more than the degree. So if there's 3, there should be 4. If there's 4, there should be 5, etc. Yes?
How many of the two ones?
Where's the second one?
The B last one?
Yeah, 1 b cubed.
Well, the other
20b? Oh no, that's what we're dividing by. That's what we're dividing by. And you don't actually have to use this letter. All you have to use is the number. Because the letter is kind of constant in all of them. That's the whole beauty of this method, is it's going to look really simple. All right, now put yourself aligned about an inch or two, or in your about a full, give yourself a row, and then put a line. Now again, if you follow along, this process is quite simple. If you don't, you're going to look at me like it's Chinese. The first number always comes straight down. 1. Everything that comes below that line, we're going to multiply by what's in the box. What's 2 times 1?
2.
That goes above the line. Everything above the line, you add. What's 8 plus 2? 2 times 10? Negative 20 plus 20? 2 times 0? 0 plus 0? Now the last number is always your remainder. Ideally, you'll never have a remainder, but you will sometimes. Now, watch this. This is you're done right now, and all we have to do now is put that back into a polynomial. What degree did we start with on this problem? 3. So you go down by 1 because we technically divided by b as well. So we're going to go down 1. So instead of b cubed, we're going to have 1, because that's where the 1 is, b squared plus 10b, and that's it. You're done. Now, technically, if there was a number here, you would have to put like plus 7 or something, but there's not, so no point in putting plus 0.
How'd you get these things?
You just come down 1 from where you started, every time. If you started with b cubed, then you're going to start with b squared.
Okay, so the 2 is in a little half box.
Mhm.
Why is it there?
Because that's essentially what we're dividing by.
This is confusing.
Okay.
It's confusing because you're look. I get that. Because you're looking at it and you're thinking, how does this have anything to do with division? But some genius a long time ago discovered that this method could really just speed up the division process. It's kind of cool how it works like that. What?
Why have we never been taught this?
I'd be surprised if you haven't.
I've
No.
never.
Y'all never did this in
I've
Algebra 1?
never seen this before.
Well, something new! Okay. Now, that's it. We're going to do 2 or 3 more examples.
See, because when you said it, I was like, I don't think I've heard of that.
No, I think we did.
I wasn't, see, I don't teach, I've never taught Algebra 1, so I don't know what they teach and what they don't.
Can you do it like distributed property?
No, because you're not multiplying, you're dividing.
I wonder how we do it.
Here we go, let's do another one.
We must have did it the long way.
Has anybody got that who wants it?
I'm still confused on it.
We're going to do more.
Okay.
It'll become clear as we do more. All right, 23. Let's do 23. All right, what goes in the box?
-4.
Negative 4, the opposite of the number that you're dividing by. So now you write down all your coefficients.
Wait, I gotta write the phone.
Okay.
N plus
The coefficients are the numbers in front of the letters. What's in front of n cubed?
2.
N cubed.
1.
1. What's in front of n squared?
2.
What's in front of n?
5.
Negative 5, and then 12. Now this one's not missing any terms. It goes nicely straight downhill. Third power, second power, first power, no power. So we aren't missing anything, so we don't have any zeros. Drop your first one. What do I do with that 1 now?
Multiply.
By negative 4. And that number goes there. The product of these goes there.
What time we got here today?
I don't know. I don't know.
Like 10.
Now, what do I do with those 2 numbers now?
You multiply.
No, you were right the first time.
Multiply.
You add them. Everything above the line, you just add with what's above it. 2 plus negative 4,
Okay, so you're doing addition.
yes, is negative 2. Everything below the line, that's right, negative 2 times negative 4 is 8. We add again. What's negative 4 times 3?
What?
Negative 12.
Why are you doing that?
No, why
Every-
are you negative 4 times 3?
Everything below the line you multiply by what's in the box. Everything. That's where these numbers are coming from. Negative 4 times 1 was negative 4. Negative 4 times negative 2 was 8. Negative 4 times 3 is going to go here.
That makes sense.
Negative 12. It's kind of a flow chart. And then 12 plus negative 12? 0. Sweet. No remainder. Which means it divides evenly.
What if it
Well,
wasn't
happy to
0?
have
Yeah. What?
What if it wasn't 0?
I'll show you that in a minute. It's not a hard thing at the end. But okay. So what was our degree when we started?
3.
So what's our degree now? 2. You come down 1 every time. You come down 1 every time. So we're going to start with 1 into the second minus 2n plus 3. And that is after you've divided it. There's your answer.
So how'd you get the 1?
It's right here. 1, negative 2, 3. And you always should start with 1 power lower than where you
Okay,
started.
how
So
did you get?
Just skip all that, James, but where
Oh,
did you get
I don't
the
do
negative 4? So you take negative 4 and multiply it by 2?
from here, I took that number times negative 4.
And then where'd you get negative 2 then?
Added.
Added, okay, then where'd you get negative 5?
Multiplied by negative 4.
I mean, look. you
No,
said
that was
negative-
in the problem. These came straight from the
Look,
problem.
the 8.
Yeah.
You take negative 2 and multiply it by 5 or negative 4 times 5?
Everything below this line, you multiply by negative 4.
Okay, and then you just put that answer right below and then you subtract it.
That's what these arrows are. That's where that answer always goes. And then
Okay.
you add with what's directly above.
Then you just add, okay, straight down.
They do
So
all
will
those
always be
problems.
add
Sure.
straight down.
Yeah, always add straight down.
What
Okay,
about
thank you, that's
29?
where you lost me.
I'm sorry. The reason, by the way, you have to plug in a 0 if you're missing a term is because if you don't, these aren't going to match up in the end. You're going to be missing a term. So it's important. We're actually going to work through like as many as we need to. We'll just work our way straight down the page. Questions on that one before we move on? Now, before we start on 25, look at 25. Someone tell me a potential problem we might have with it. Yes, sir.
I'm talking about the one that we just did.
Oh,
So
yeah, okay.
where'd you lose the N3?
Because if this 4 wasn't here, right?
Okay, so you just take that in and go.
Yeah,
"Oh,
see,
fine."
the whole process, it kind of takes away the necessity of dividing by the letter, but in the end it already did. Because all these have been divided by n.
Okay, yeah, I get you now.
Cool. All right, look at 25. What is a potential problem we might have with 25?
Would it be that the
There
x
ain't no
to
decimal.
the second?
There's no, just the F.
Well, I think what you're meaning to say is what...
Because all the other ones are huge.
Well, no, it can be as big as it wants. It can be x to the 7th, x to the 57th. Of course, you'd have a ton to do. But where we're going to run into problems on this one is we're missing a term. There is no
You
x.
put a 0 on it.
That's right. It goes 4, 3, 2, 0. We missed a 1. So when you start working that problem, you have to put in a 0 for that. So here we go.
Do you do X for 0 or just
Just 0. So what's going to go in our box? Negative 2. Shh. All right. So coefficients. 1, negative 3, 1, 0, because there's no x term. Negative 5. Do not forget your zeros. That will be killer.
Forget your 0, got it.
Why'd you put a 0 there?
You two need to stop talking or I'm going to freaking lose it.
No, man, I always take a 0 at the end. Why'd you-
Wrong. You need to stop talking. We put in a 0 because there's no x term. It goes 4th, 3rd, 2nd.
And you have to put a 0 for where there's not a number.
Exactly. Well, wherever you're missing a descending variable.
Yeah.
If you had started with the 7th, x to the 7th, then it should go x to the 7th, 6th, 5th, 4th, 3rd, 2nd, 1st number. And if you're missing any of those, you have to plug in a 0 for them. Okay. Now,
See, you think I was talking and not listening.
oh, right. As if you weren't talking. Matt, what do we do in our first step?
But I was still listening.
Negative 2 times 1.
In just a second we will, but what happens to the one first? it just drops down. The 1 just drops down every time. Or whatever that first number is. Now, we take negative 2 times 1. You're exactly right. Negative 2. Then what do we do, Daniel?
You add them.
That's right. And you get,
Negative.
I think it's 5. Negative 5. Then what do you do, Wyatt? By negative 2. Yes, sir, you do. And then I give you 10. Then what do you do, Mackenzie?
Add 1 and 10.
That's right. Then what do you do, Juri?
Times 11.
There you go. What about now, Kennedy?
I got lost.
Okay. Well, just looking where we are, what happens when you're at this step and you have two numbers right next to each other? You've already multiplied. You just do what? Straight down. All you have to do is add them. So, you add those together, you get negative 22. Let me erase this before somebody sees it and gets confused. Oh, darn it. Okay. All right, then you multiply again. This one has a remainder. This one had a remainder. We got a number in the last spot. That's not a big deal. I'll show you how to deal with that. Okay. Cassidy, what degree do we start with when we start writing our answer?
4.
That's where the original one was. Our answer is going to start with,
Negative 2.
3.
39.
I'm asking you the degree, which is just the highest exponent. You always just take one away. So if you started with 4,
It goes 3.
very good. So 1x cubed minus what?
2.
Minus 1.
Two
Negative
X.
5.
Minus 5x squared.
Which one do you flip? Never mind, you flip it to a negative when you first start.
Get him, Tyler. Now what?
Add 11.
Add 11, but what's with the 11?
It has an X following.
An x, that's right. And then minus 22. Oh, I'm out of space. Minus 22. Now the remainder. Crap, I ran out of space. The remainder is just going to be added right next to it. It's not going to go below, but I'm out of space, so I'm going to write it below. It would go right next to the 22. But here's all you have to do. The remainder, so what is that, 39? So plus 39, except whatever the remainder is, you divide by what you were originally dividing by. So,
You
You're-
actually find it, but it's right under.
no, you don't have to do anything with it. You just write it as a division.
And you said with your remainder, what you're shooting for is to have 0, but it don't always have.
Exactly. Very good.
So, why do you divide it by x plus 2?
Yeah.
Well, if I said 10 divided by 7, that would divide evenly into 1 and 3/7 because 3 would be your remainder. And what do? You stick it over what you originally divided by. Same thing. Whatever your remainder is, you basically are saying, I couldn't divide that, so I'm going to leave that as a division problem that it was originally because I couldn't do anything with it.
Oh, X plus 2 is right
Yeah.
there. Okay.
So, you have your answer, and then right next to it, I just ran out of space, you do, if it was negative 39, it'd be minus, but it's positive, so plus 39 divided by your original divisor.
You wouldn't underline this whole thing and put X plus 2. You just
And
underline
you thought I
39,
wasn't
right?
paying attention.
It's not underlined, it's a division problem.
Well, I mean, yeah.
Yeah.
You know what's Crawford?
What?
You accused me of not paying attention.
This
I
makes
accuse you
it
of
a lot
talking.
easier.
I was talking, but I was still paying attention.
Crawford,
Well,
this makes it a lot easier.
More than I can say for the other
Two
talkers.
things at once.
Woo! What do you say?
You can do 2 things
Wait a
at
minute,
once.
I'm a
What is it
multitasker from.
Okay, how are we feeling? Right out the side door. No. All right, we're going to set up 27 real quick. 27, what goes in the box?
Box 3.
What goes in the box?
3.
We're on 27. 4. All right, the coefficients, 1x cubed, negative 4x squared. We're missing both a regular x and a number. So 0, 0. Because there is no x and there is no regular number. That's really the only thing I wanted to make sure you saw about this one, is that you'd have to plug in zeros for the missing terms. There will be a new seating chart for some of you tomorrow.
I was gonna say, would it come out the same if you didn't add the zeros, but when you multiply zero, it wouldn't come out the same.
And they won't line up as well. Alright, so drop the 1, multiply, add, multiply, add, multiply, add. Wow, zero remainder and a whole lot of zeros. What degree do we start with?
Third.
Nope. That's where we started originally. Where does our answer start? That's right. You go one down to be 1x squared.
No, but you asked me where it started, that's why I said third.
I apologize. I apologize. So it would be 1x squared and then plus 0x plus 0, but you can just leave those off because they're zeros. So really, 27, the entire answer, is just
X squared.
1x squared. Questions? All right, here's your assignment. Actually, give me 1 second.
Is it okay if it
Perfect.
How many minutes? 3 minutes?
Your job is to do these 4 problems. And they are due first thing tomorrow. Well, actually, that's not true. These will be due first thing on Thursday along with the other assignment because half of you won't be here tomorrow. These are due first thing on Thursday. You need to write those down. Who? Well, there's not very many of you in here. You can show me yours tomorrow, I guess.